Welcome back, everybody. We are up to lesson 6 of unit 3. And in this particular lesson, we're going to start looking at different types of equations involving squaring and square rooting, specifically how many real number solutions that a particular equation has. So I have some statements I want to look over and go over on the screen right now. We, of course, know already that squaring and square rooting are opposites of each other. So with that in mind, we know that the equation x squared equals 9 has two real solutions. All right, and we know that because we solve by square rooting both sides. So in this case, if we square root both sides, we get either x equals 3 or we get x equals negative 3 because 3 squared is 9 and negative 3 squared is also 9. So anytime you have x squared equals a positive number, that's going to have two real number solutions. If I had the equation square root of x equals 9, that's only going to have one real solution. So again, the positive square root of x equals 9 is only going to have one real solution. And I'm going to solve that by squaring both sides because squaring is the opposite of square rooting. And if I do that, I get x equals 81 because the positive square root of 81 equals 9. If I changed that to a negative 9, so let's say I had the equation the square root of x equals negative 9, even though it looks like it's solvable, it actually is not in the real number system. It has no real solution because you can't have a positive square root equal to a negative number. So what this means is positive square root of x equals negative 9. That would mean a positive number would have to be equal to a negative number, which is obviously not mathematically possible. So when you have the positive square root of x equals a positive number, that's going to have one solution. But if I have the positive square root of x equals a negative number, it's not going to have any solution. It's going to have no solution at all. So with that in mind, let's take a look at the examples here. So find the real solutions to each equation if there are any. So in number 1, I have x squared equals 100, okay? So I can solve that by square rooting both sides, okay? Why? Because I know that squaring and square rooting are opposites of each other. So essentially, the square root will cancel out the squared. So that will give me x equals, the square root of 100 is going to be positive and negative 10. Remember, when I solve an equation by square rooting, I have to do plus and minus because 10 squared equals 100 and negative 10 squared also equals 100. The same thing is going to happen in number 2. I can solve that equation by taking the square root of both sides in order to get rid of the squared, in order to cancel that out. And I end up with, in this case, z equals positive and negative square root of 25 is 5. Okay. Number 3, I have the positive square root of y equals 10. In that case, I'm still going to do the opposite, but the opposite of square rooting is squaring. So I'm going to get rid of the square root by squaring both sides. Okay, the positive square root of y equals positive 10. So in this case, the squared will cancel out the square root, and I'll be left with y equals 10 squared, which is 100. So number 3 only has one solution. Number 4, okay, now we have the positive square root of a equals -1. The positive square root of a equals -1. This goes back in our lesson notes to that third example in the lesson notes. If I have the positive square root of x equals a negative number, it has no solution, no real solution. So we're going to say that number 4 has no solution. Why? Because this is saying that a positive number equals a negative number, which is not mathematically possible. Now, I should add that if I change number 4, so let's say I change number 4 so that it said this. So if I changed it so that it said negative square root of a equals -1, it would be solvable, because this would be saying that a negative number is equal to a negative number, which is possible. Okay. In number 4, this is saying that a positive number equals a negative number, which is not possible. So to make it solvable, all I would have to do is put a negative in front of the square root. All right. Number 5 looks interesting. It looks different because I have a square root on both sides of the equal sign, but the key is these are both positives. I have the positive square root of w equals the positive square root of 2. So this indeed is a solvable equation in the real number system. I can still solve this by squaring both sides. Okay, the difference is this time is going to be that on the left-hand side, squared will cancel out square root, and I'll be left with w. And on the right-hand side, squared will also cancel out square root, and I'll be left with 2. So I'll have w equals 2. W equals 2. So to sum up this lesson, if I have x squared equals a positive number, that means it has 2 real number solutions. If I have the positive square root of x, or in this case y, equals a positive number, so positive square root equals a positive number, it only has one solution, like in number 3 and in number 5. If I have the square root of x, or in this case it was a, the square root, positive square root of a number equals a negative number. So positive square root equals a negative number. It has no solution because it is not mathematically possible for a positive number to be equal to a negative number. That is it for this lesson.